Hi, this is Gary Rubenstein. This is the 17th part of a series of videos taking you through math, starting in kindergarten and working our way up. And we're into geometry now. And I've done two videos about the few things that I think are really important to, like, facts to know about geometry. And it's true that in some schools, maybe they just learn a bunch of formulas, memorize them, learn to apply them. And that has some use in the real world. Um, but geometry is part of the math sequence, mainly because of the way it's um, it's a system of of proving things in math and building theorems and building up math, which it's not as relevant. Long ago, there was not so many other things to do in school, um, computer programming, or just you can name so many different electives that they have nowadays and different types of literature that you study. So 2000 years ago, this was really a big thing. And as time has gone on, it's not really as relevant as it used to be. I mean, I love geometry. I the what can I do with these, like, most basic starting points, and how far can I go with that? Um, but is that really such an important thing that everybody needs to study it? It would be like forcing everybody to learn how to play the harp. It's not. Learning to how to play the harp is a good thing, but it's sort of a specialized thing, and not everybody is going to like playing the harp, and not everybody is going to want to do it. And there's other things you can do besides play the harp, and you have to decide, should we make everybody play the harp for a year, or are there other things that they can do with their time that's just as good as playing the harp, if not better? And I feel that way about geometry. um, I don't think that geometry should be a required thing, and it actually isn't required in most schools. I mean, most school systems, if you go up to algebra, that's enough to graduate. But maybe it's looked down upon a little bit. Oh, you didn't do geometry? Why not? Um, Nonetheless, I want to show you sort of a modern, something I really like to do in geometry that's sort of more modern, which is to use what's called a dynamic graphing program. And the way this works is, you make some points. Okay, so that's like a drawing program, and you make some line segments connecting those points. So that just seems like just a drawing program. But what makes it dynamic is if I click on this arrow here, I can actually move, the points around. But if a line segment was created by joining two of those points, it remains a line segment. So what you can do with that is you can get sort of an informal idea of how to prove, or how to at least see what's going on in geometry. Oops, I went the wrong way. So if I click on 3 points in a clockwise fashion, it measures the angle there. And if I do that again, it measures that angle. If I do that again, by the way, this program I'm using is called GeoGebra. It's a free program online. You can download it, or you can use the web version. And here we can see that the angles, as I move the points around, the angles change. Now, let's say that I want to see, what happens to the sum of the angles. So I can come over here. Actually, I can come over here, and I can add together the three angles, which I'm going to do here. So the first one, it uses Greek letters, which is a little bit annoying, but alpha plus beta plus gamma. And I hit enter. and it adds it up here. And if I drag this onto the screen, see that equals 180. But if I move this around, notice how all three angles are changing. They're changing their measurement. Whoops, don't do that. But this 180 looks like, well, that's, what is that, stuck? Well, no, it's not stuck. It's actually continually recalculating, but it's staying as 180. Now, that's not true for instance, um, the area of the triangle. I think to do the area, I have to click on the 3 points again. And I can come here and say measure area. Okay, so there's the area. And you can see when I move the 3 points around, that doesn't stay the same all the time. That changes, but the sum of the angles does not change. And this gives us a little like conjecture into why into like what the rule might be. You could even do something that's kind of like a proof. I could draw in a parallel line. And what's neat about this is when I change points A and C, that line remains parallel. And then if I put a point here and a point here, I can come here and say um, angle. And I have to go clockwise, so I go like that. And if I go clockwise this way, it looks like that. And this gives us a little more, we can see now, like not just, yes, the angles add up to 180, but we see a little bit more of why the angles add up to 180. This angle here, which I could change the color to make it more easy to understand. And this one, I'll make blue. And now, as I drag the points around, we can see how these three angles add up to 180, and therefore so do the original three. So this is something that you do nowadays with modern technology, and it makes it to me a lot more relevant because students get a chance. You make these activities, either the students create them themselves or you make them into activities, and you say, okay, drag around point C. What do you notice? Because that makes math kind of like science in that way, like observations, like, okay, I noticed something, and then you try to prove it. In science, you know you you prove things, or you get support for conjectures. In math, you prove them and they become theorems. I'll show you a couple of other of those things. Yeah, you might remember I showed a couple of Pythagorean theorem uh, proofs. So here's one that's real pretty looking. When I move this slider around, you can see the pieces move so that the 5 pieces sort of cover up the big square. I'll even move this around, move these around. So this is sort of a modern thing, and I feel like it makes geometry a little more fun, a little more relevant, perhaps not as relevant enough to make it worth, subjecting so many people to. But as I mentioned before, like the harp, there, if you get the geometry bug, it is an amazing thing what you can do. It's like a game where you try to prove things, and how far can I go with these limited tools. But as far as like what do you need in geometry from life, well, I mentioned those in the last couple of videos. A couple of basic things about triangles and circles, um, but you can get through life perfectly fine knowing just maybe 1 hour's worth of geometry. So, uh, but I did want to show you because you're watching these videos maybe, and you want to know, what is geometry and why do we do it? Um, I don't know if in 20 years, if geometry will still be a thing that we spend a year on. I hope some people do, but um, I think there's so many more things to learn nowadays that maybe geometry doesn't deserve, you know, I love it, like I said, but how much money a year is spent on teaching geometry, um, at least I'm talking about the high school subject, certainly in elementary school, geometry is a good thing where kids learn their shapes and it gives them opportunity to like do some reasoning and notice some things. And I do like that part. I'm talking about the 11th grade geometry course, the full one with the proofs that started in 300 BC and continues to this day, whether that course is so relevant anymore. There's no bad math. Math is either thought provoking uh, or not. Some math is thought provoking. Some math is thought provoking and relevant. And to me, the main thing is that it's thought provoking and it's worthy of studying. But for students, they also like to know sometimes that it's relevant. No matter what I'm teaching, I try to make it thought provoking, whether it's relevant or not. And I don't make relevancy the metric by, this is why it's important. It's, just like reading Shakespeare. Do we need to? No. We could get by just fine without reading it, but we read it because it's thought provoking. And maybe we like it enough to become, read Shakespeare, you want to become a playwright, or you want to go to more plays because you like this. And maybe because of what you do in geometry, you decide, I really like this thinking about things and trying to prove them. I think I'm going to go and be a scientist because they think about things and try to prove them. So it's not that it's a bad thing. Like I said, I really like it. So you want to get as much as you can out of it. And that's what I wanted to say about geometry in this final geometry video. Coming up next, trigonometry.